This is Organic Chemistry 22, section 22.1 to 22.6. Organic Chemistry. Now, what I'll do, this will be several videos. I don't know how many it'll be exactly. But after you've watched all the videos, go through and do on the worksheet the packets, all pages of packet 1. I'm gonna say either packet 1 or I'll put a different direction if not. And then there's another packet that says a self-study packet. Those, if you want to read through that self-study packet of Zoomdal, you can, but you don't have to. You can just skip all the way through the whole work. I think most of it's near the back, but anytime you see a circled problem, by hand circled, you just do those circled items. That's all. And then I might give you some extra credit problems from your textbook. And what will happen is, after the break time, sometime after the break, like it won't be immediately when we come back from the holidays, but it'll be like, I don't know, I'll give you like a week notice probably, but there may be a little quiz on this, and so that's a good thing. It won't be a test, but it's a good bit of information. All right, organic. Now, there's also a handout, notes outline I'm going to give you, and I printed it this way. We'll print it this way, like sideways, just so you have more space to draw and write these things down. Okay, organic chemistry. Now, I've mentioned this before, but all chemical substances that are plant or animal, anything that is organic, is made up of just these elements. Mostly carbon and hydrogen, hydrocarbons. CH and O. There's a little acronym, SHNOPS. Maybe you've heard of that before, but that's pretty much all of the elements that deal with in organic chemistry: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Now, we have actually not gone over bonding yet, so it's interesting. I mean, like Lewis dot diagrams. I did do that. Actually, we did do. A lot of you have done that, but it was not required. It was an extra thing. If you can do Lewis dots, it makes it a whole lot easier for you. And you can watch some of that as well. You can watch some of the old Lewis dot lessons. But anyway, but what organic chemistry is, pretty much in AP, what they want you to do is it's more nomenclature, more things to name and write structures. So for example, they'll say, you have ethanol. Draw the diagram for ethanol. Draw a Lewis dot diagram for ethanol. Write the formula for ethanol. You're like, what is that? Okay, ethanol is the alcohol that's in like drinking alcohol, among other things. But that's an example of an organic compound. They pretty much want you to know how to name it and write the formula. So it's kind of like nomenclature that we did earlier in the semester. We learned all this naming. But now this also involves drawing structures. And a really cool thing, which we won't really be able to do it online so much, is play with the organic model sets and build these molecules. I might possibly hold some up now and then and show you. But interestingly, what we're doing will kind of come into play when we go over bonding chapter. So it's kind of like, if you want to think of it, this is something that'll get you a head start before we get into all the bonding. And you do need to know it. And so it's something you could do even without knowing. You don't have to know any Lewis dot diagram or anything like that. And I'll tell you the shortcuts of it. And if you know that, it'll help you even more. All right. So here we go. First of all, let's talk about what are hydrocarbons. The basic kinds of hydrocarbons are called alkanes. A-L-K-A-N-E. Now, most plant, animal, not when we say organic, it can also be things that are either natural or synthetic. Drugs, medicines that you have, a lot of them are organic. Obviously, they go into your body or into an animal's body, whatever, treat. But they have carbon chains in them. Carbon links together in a bond, one carbon to another, to another, to another. Carbon is kind of like the skeleton or backbone of these organic molecules. Now, the alkanes are the most simple type, and they're called saturated hydrocarbons. I'll tell you about that word. Well, it tells you, there's a definition right there. Every carbon in a chain forms only 4 single bonds. Hydrogen fills every position outside the carbon branch. Now, there's another thing you can remember. First of all, there's CHNOPS. You don't really have to know that. I'm not going to be asking you that really, but you'll just know that those are the elements that are pretty much in organic compounds. But here's another one that you can kind of remember if you don't know the Lewis dot diagram, or even if you do know it. HONC. 1, 2, 3, 4. Now what this means is, whenever you see a compound, carbon in the compound will always form 4 bonds. Nitrogen will always form 3 bonds. Oxygen will form 2, and hydrogen 1. Now if you want to be even more specific, hydrogen will just form 1 bond to something else. Oxygen will form 2 bonds. And not only will it have 2 bonds, it will also have what's called 2 lone pair. So a bond counts as 2 electrons. It's probably good to know that. So 2 electrons would be between hydrogen and just whatever other element you have there. Oxygen would have 1, 2, 3, 4, 5, 6, 7, 8 electrons, and an atom here and an atom there. Hey, how about putting H and H, H2O, haha. Okay, nitrogen will have 3 bonds, so it'll be like this, bond, 1, 2, 3, and then it will have 1 lone pair, and you can also have H's around it if you wanted to, and that would be ammonia. Or carbon will have 4 bonds, bond, and nothing around it. Now, let's talk about this one for a moment. Carbon, when it has 4 bonds around it, and you put a hydrogen in every place, we say that carbon, that single carbon, is saturated, okay? Saturated with hydrogen. Now, we call that compound methane. And you've heard of methane before, methane gas. All right. So, let's watch this for a minute. What you're going to do, we're gonna memorize some counting. Now, you already know mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Don't you know that? I think you do. Okay, hopefully. All right. And then if you've done geometry, shapes, there's a counting for that, but I won't do that one. Excuse me. But what I'm going to do here, methane is a compound, the most simple organic compound. It only has 1 carbon, and every bond it makes is a single bond to hydrogen atoms. Call that methane. All right, ethane will be the second one. Ethane has 2 carbons. I'm going to put a carbon to another carbon. Now, these 2 carbons are also going to be saturated. That means every space that is not occupied by a carbon will have to have a hydrogen. So, in other words, here's a better way to say it. HONC, 1, 2, 3, 4. Carbons need 4 bonds. This carbon has 1 bond, 2, 3, 4. This carbon has 1 bond, 2, 3, 4. And these are all going to be hydrogen, 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 and hydrogen. Okay, let me kind of get that one out of the way so I won't mix it up so much. So, this is called ethane. Ethane has 2 carbons. Now, there's another way to write the formula for methane, and once you write this down, you can see it's CH4. Ethane, you can write it a couple of ways. One way you can write it is C2H, and then just write down how many H's there are. 1, 2, 3, 4, 5, 6. C2H6 is ethane. Now, there's another way you can also write this, and you might see this as well. AP can do all this. CH3, CH3. So this is ethane, and this is ethane too. Now, why would you want to write it that way? This kind of shows you the structure. Like the first carbon has 3 H's on it. The next carbon also has 3 H's on it. So that's how you can do it. So methane, ethane, and now we're going to go to propane. Propane is the third one, and I'll put it down here. I hope it will fit. I'm going to have to do a lot of erasing. I guess I have to erase a lot here, especially if I draw so big. But for propane, let's see. You know what? I'll draw it down here. C. It has 3 carbons. Now, each carbon will have 4 bonds. So it's going to be H, 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 H. Let me take away the name from it, propane. So there it is. Now the overall formula is C3H8. Now notice 1, 2, 3, 4, 5, 6. In the middle have 2. Or you can also write CH3, CH2, CH3. So this kind of tells you the order. It tells you a little bit. It's a little bit sort of a way to write this down. CH3, CH2, CH3, like that. Okay, they're both acceptable. Methane, ethane, propane. Okay, you might be noticing a pattern here. You might or might not. But for alkanes, it's CX, then H, or how these were N. I'm sorry, CN, then 2 N, 2 times N, plus plus 2. Is that right? Yeah, 2N plus 2. I think that's how you do. I'm getting it right. C, and if that's 1, 2 times 2 is 2 times 1 is 2 plus 2 is 4. 2 and 2 times 3 is 2 times 2 is 4, 5, 6. 6, 8. You know, I don't even use that formula. That's why I'm not to figure it out. You can look in your book or whatever if you wanted to. But anyway, I just write them down, and that way I remember it that way. Now, before I move on, I want to show you something that you can do. All right, for methane, there is no shortcut. There is a shorthand method that organic chemists like to use. Oh, and by the way, I don't think I told you. In AP, the book has a lot of information in it. Kind of like the thermo chapters are. But we don't have to do all of it. You know, we only need to know pretty much the nomenclature. Maybe some reactions. And I might make another video and do a little bit of that later on. But perhaps a little bit of reactions, and I'll tell you a couple of them during this time. But it's mostly nomenclature. So it probably turns out to be maybe just like half or a little less than half, between 1/3 and 1/2 of what your book has. But there is a shorthand method. When you go to college, so we're going to do this for just a few hours of organic chemistry. But when you go to college, you'll take a year of organic, maybe 2 or 3 classes of organic, okay? So, oh my goodness, and it all starts here. So after you had all this chemistry, then the next year, after your second year of chemistry, you know, after you've done all your first year chemistry stuff, then you get to college and you do organic. Like, what? There's more, and all of organic just deals with these kind of compounds. It's fun, it's neat stuff. So here's what I want to show you, a little shortcut, shorthand thing. Okay, for methane, there is no shortcut. If there were, you just draw a dot. What would that mean? But I'll show you in a second. For ethane, the shorthand method is just to draw this, a line. Now, what does that line mean? What is that? That is a compound? That's ethane? What organic chemists understand is that this line represents a bond, the one bond between the carbons. All you're going to draw are the bonds between carbons. Now, it will be assumed and known that every other bond will be a hydrogen. So we're not going to draw these. I'll put them on here for now for you to see it. But we will assume that there's a hydrogen here, and a hydrogen there, and a hydrogen there. There'll be one there, and there, and there. Now, I kind of did it like that, like a little tripod sort of looking shape. And there's a reason for that. You don't have to, though, but we're not even going to draw that really. But so if I have a carbon right there and a carbon right there, then I have H, 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 H. So in organic, we just know that whenever you see a carbon, it has 1, 2, 3, 4 bonds. So the bonds you don't see have to be the hydrogens. That's the point. So things that are, the bonds that are to other elements, will draw them. So ethane will look like that. Like, what in the world? Now, propane will look like this. You're like, what is that? Okay? Because this is actually, let me move it over a little bit, and it'll kind of make some sense. Poor propane, I keep erasing it, but I'm going to draw it like this. Actually, I think I'm going to make a diagram for you on this. This is a carbon, and that's a carbon. The first carbon has 3 H's. So, like I told you, there'll be 1, 2, 3, 4 bonds. One bond here for this carbon. One bond, then H, H, H. So there it is, H, H, H. The second carbon will have a bond to one carbon and a bond to the other one. All right, one to the left, one to the right. But then you're going to have two H's on there as well. And they're really, actually, they're going to be up like that. This carbon will have HHH, 1, 2, 3. So methane has nothing. There's no shortcut for that one. Ethane, you draw a line. I mean, if you wanted to, you could draw the line that way. If you just want to go make it diagonal. But oh well. So methane, ethane, propane looks like that. And number 4 is butane. Methane, ethane, propane, butane. And butane looks like this. And so you're going to just keep adding on and on and on. Let me see. Maybe I can make propane for you real quick. My little boy was playing with this stuff. He was playing with these, and he might have made a mess out of them. Oh, my goodness. But we'll see. All right. Yeah, some of the bonds are like the wrong size. But I think I'll be able to do it. Because I'm taking apart some other things that were put together. And I'll show you how this looks. This is a fun thing to do in what I normally do is you watch this video, and then at some point when we get back to class, or if it's a special day that we meet outside of school time, I'll give you guys a set of molecules and you have to build these things. Build them. If you really wanted to be like, if you know you're going to study chemistry in college, you know you want to do anything with health, medical profession, dentistry, nursing, pharmacist, anything like that, then you ought to just buy a set. It's I have this one. It's this inorganic model set, and it has this kind of stuff in it. You can build them. But anyway, I mean, I don't make money off of that. You can go whatever company you want. But anyway, look at this. This is propane. Now, so propane is CH3, CH2, CH3. So this C, carbon is the black one, has 3 H's. Then this C has 2 H's on it. Then CH3. So there it is. And so when we draw it, you can't really get an idea of the three-dimensional, the shape of it. I can hold that really close like that. You can't really get an idea of that unless you have a set. But anyway, there it goes. So methane, ethane, propane, butane. Now, I'm going to make this a little bit easier. I'm not going to sit here and draw every one of these. That's why we do the shortcut. But in fact, I'm running out of space too. I guess I could draw them a little smaller and it'll be all right. But so if I just wanted to draw these out, methane on the paper asks you to draw all of them. So methane, I'll just put the dot. Ethane, propane looks like that. Okay. And again, what is propane? I told you you can write C3H8 or CH3, CH2, CH3. Butane, I didn't really write the words down, but methane, ethane, propane, methane, ethane is there. Propane, I'll put propane, whatever. Propane is there. Butane. Okay, butane looks like this. So now we could keep the diagonal going. And all I would do is I would just add another carbon onto one of these and keep it going on and on. It'll be actually it's kind of looking like up and down, jagged, up and down, up, down, up, down. Okay, so butane will be how many carbons? So every corner is a carbon. 1, 2, 3, 4. See, 4H. This has 3 and that one has 3 always because they're on the ends. But the middles will always have 2. CH3, CH2, CH2, CH3. Or another way to look at it, 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Or we can write CH3, CH2, CH2, CH3. That's butane. All right, now, I'll just tell you the way they go right now because after butane, it becomes just like geometry. And on the paper, you probably can figure this out. 1 is methane. So 1 carbon is methane. Methane, 2, ethane. 3 is propane, 4 is butane. Methane, ethane, propane, butane. Then, what is a 5-sided object called in geometry? Pentagon. So it's pentane. So it's just like, now it becomes like the Greek prefixes. So 1, methane, ethane, propane, butane. Pentane is 5. 6 is going to be hexane. 7 is heptane. 8 is octane. 9 is nonane. And then 10 is decane. So methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. You want to be able to count like that. All right? So pentane, has 5. 1, 2, 3, 4, 5. And it's the same thing over and over again. C5H10, CH3, CH2, 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 CH3. All right. For Pentane, hexane. For hexane, we'll put 1, 2, 3, 4, 5, 6. So C6H. And this will be, oh, I messed that up. Bad Vela, that wasn't 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. See, I was just doing it so quick. So this is C6, 1, 2, 3. I'm just counting the hydrogens. 3 and 3. 1, 2, 3, 4, 5, 6. These have 3, 3. It's 6. Then 2, 2, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. C6. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I left off one of my little things. Boy, I'm counting it. I'm trying to do it so quick, and I'm not looking at all the stuff. So the ends always have 3 and 3. That's shortcut. Now, let me say this. On the AP exam, they never draw these, and if you draw that, if it says draw butane, you draw that, you will not get credit. What you'll need to do is you'll have to draw the structural formula would be to do this. To draw butane, you'd have to draw 4 carbons, and then 3 hydrogens on the first one. So just like we saw a moment ago. Then 3 on the last one. And then in the middle, you draw those as well. So why am I drawing this? Well, what I would say, it makes it easier to memorize and learn it and do it quick with this form. But when you have to actually draw it, you do this. So if it were the AP, it said, draw a molecule of N-butane. We'll talk about what that means, normal butane. Well, I would just real quickly go 1, 2, 3, 4, that's 4. Then I would look at that and say, okay, that's CH3, CH2, CH2, CH3. So it's okay to have that on your paper, but make sure you have the correct one, or if it says in the box or whatever, make sure you draw this one next to it. Okay. Also, let me bring this back. They can put on the equation section, they'll say, write an equation, net ionic equation for the combustion of butane. Now, you could draw that if you wanted to, plus oxygen. But what I would do for that one is just write what we saw earlier. I would draw that real quick. Say butane's 4, C4H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. And by the way, the combustion of butane is just going to be hydrocarbon plus oxygen. And can you remember what you always get there? You get carbon dioxide and water. That's all you have to do for that one. So, in fact, as far as equation predictions, and I'll mention it later, this is the most, one of the most common equations, not just for butane, but I'll do this. Let's say you have C6H5. This equation is one of the most common one ever asked on AP, a lot. And they can even make another version, CXHYOZ plus oxygen will also give you CO2 and H2O. So that is one that you need to know that reaction. I mean, you've already seen it before. And then I'll mention one other one that's a neat one later on. Okay, so we got methane, ethane, propane, butane, pentane, hexane. Now, let's just keep on going and show you how the other ones go. Then 7 is heptane. Heptane is 7. 1, 2, 3, 4, 5, 6, 7. Octane, and you've heard of octane in gasoline. 1, 2, 3, 4, 5, 6, 7, 8. So I'll at least draw this part. So heptane is C7H16. So you double it and add 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so, and then octane is C8H18. And then nonane, don't hear that one too much. Okay, C9H1820, I guess. 1, 2, 3, 4, 6, 7. Yeah, and then decane. Decane has 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure every corner, and then every time you turn, it's a carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C10H22. All right, so I'm not going to draw all those. So now you know the alkanes. Yay! Okay, so now you've memorized the alkane groups. All right, and there are more after that, but pretty much up to 10 is all you need to know for most any organic. I mean, your sets, you can't even build those on these molecule sets because you run out of carbons. Okay, now the next thing on the list here was to talk about isomers in 22-2. I don't have all of the sections numbered, but I'll just be going through the pages. So, what in the world is an isomer? Okay, an isomer is a molecule, well, I'll just say having two molecules, and both of them are made of the same atoms. They have the same molecular formula. If you remember what that is. The same molecular formula, but they have different bonding in them. Okay, let me start off with butane. And I mentioned this earlier. In butane, like a normal form of butane, if I want to draw butane, then it would look like this. 1, 2, 3, 4. And I'm going to put all the H's around it. Now I just jumped ahead and did this. Didn't need my little shortcut. Okay. There's butane. All right. Well, there's also something called isobutane. Now, I'll draw it, and then I'll tell you something else about it in a moment. But here's what happens. Okay, I could actually build this and show you too. But what I'm going to do here is I'm going to draw a carbon. Let's see. I'm going to break off this bond of this carbon, and I'm going to attach it to the middle right there. So it would look like this. Carbon, carbon. I'll tell you what, it would be good to do this. 1, 2, 3, 4. Now here's what I'm going to do with iso. And this is a fun thing you can do as well. All right, let's just take that one and make it yellow. All right, I'm going to break that off. And what I'm going to do, maybe I'll put it up here. I'm going to put it up here. So let's just draw this. Take off the yellow, and I'm going to put it right there. What in the world? How strange that looks. Okay, so here's how it would translate in a formula. I'm going to take this part here, the CH3, I'm going to put it on top right there. Carbon, H, H, H. Now, does this carbon have 4? What is it for? 1, 2, 3, and of course to there, 4. This carbon has 1, 2, 3, and it would have to have one more H down here. This carbon would have 1, then 2, 3, 4. So that is called isobutane. Another way that a lot of times the way we draw iso group, just think of an iso as looking like this. Kind of like a little Y, like a Y, and I'm going to go straight out with it. So it's a Y, because see, the middle carbon right there it's attached to a CH3, a CH3, and a CH3 in 3 directions. CH3 there, CH3 there, and a CH3 here. C, 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 3 H's, 3 H, 3 H. And it has one more H there in the bottom. Now, to show you what we mean by isomer, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10. It's C4, H10. This one is also C4, H10. So they both have the same molecular formula, C4H10, C4H10, but the bonding is different. That's what we mean by an isomer. Now, okay, before I move on, let me tell you one more little thing kind of weird about this. This is just something general about naming chemicals in organic. Now, when we name a compound like copper 2 chloride or copper 1 chloride, hopefully you know copper 1 chloride is CuCl. Copper 2 chloride is CuCl2. You could write that down. Well, there's also something called, there's an old naming method where they called it cuprous chloride or cupric chloride. Now, you might not have heard of that, but you might see it somewhere. You could look it up if you wanted to. And you don't have to know this. You don't have to know it. But I'm just going to tell you anyway. Anytime, or how about this? Iron is ferrum. Ferric and ferrous. Cupric, cuprous. Titanium, titanic, and titanus. O-U-S. So titanic and titanus. what the ick is always the form of the metal that has the higher common charge. Okay, so like copper 2 is more common than copper plus 1. Copper 3 is very rare. Okay, but copper 2 really almost not, you don't even see it. Copper 2 is the higher charge, is cupric. Copper 1 is cuprous, the lower charge. You don't have to know any of this ick, us, any of that stuff at all. That's an older form of naming that you might still see if you look at some chemical bottles, some countries, maybe even Britain, or actually biology chemicals, sometimes they name them the old names still. So there's a lot of common names that are around in chemistry, and we use them a lot, but you're not required them on the AP. Well, it turns out that isobutane is a common name that doesn't really turn out a lot. There's another way to name it, and but I will tell you, you've heard of iso before, haven't you? Isopropyl alcohol, and that will come up during this lesson. So that's a common name for something, but the official organic naming method, I'm going to be teaching you that. We actually call this something else. Isobutane, there's another name for that, and you're going to see that later. Okay, but anyway, N-butane, isobutane, we've got it. Now let me go with another one. Actually, I can just keep these papers here. This picture here. The next one says, what about in pentane? Okay, in pentane. Penta is 5. 1, 2, 3, 4, 5. I'm going to put H's around that one. Okay, so this is normal pentane, just straight out in a chain. But you can also make an isopentane. Okay, so this is in pentane. And by the way, pentane is C5H12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or if you want to draw the 1, 2, 3, 4, 5, there's a little shortcut for it. Okay, isopentane. Here's what you'll do. If I want to draw isopentane, let's just draw our Y for a moment. So that takes care of 1, 2, 3, 4 carbons. So 1, 2, 3, 4. That's isobutane. Then isopentane, we're going to go up. So 1, 2, 3, 4, 5. And you can make it up like that. So 1, 2, 3, 4, 5. That's isopentane. Now, if I had to draw the actual structure of isopentane, I would draw carbon, carbon. Let's see, 1 carbon to another carbon. Then I'll go up and draw a carbon here. So I'm going to kind of draw it the way I did a moment ago. I'm kind of running into my diagram. Oh well. Then, of course, that one will have an H there. That's just 3 of them. It's kind of hard to do it like sideways like that. It didn't look exactly like. I mean, you could do an angle if you wanted to. Then this goes to another carbon. The point is to keep up with your carbons. Carbon goes to the center carbon. Well, whatever you'll call it, the middle carbon. And it goes to another CH3. So these 2 branch off from there. Then you get another carbon. Now this, and then it goes to another carbon. Now this carbon has how many? Let's think how many H's are going to be on. This carbon has 3. This carbon will have 3. That one will also have 3. But that one will have 2 carbons. Because remember, you need 4. 1, 2, 3, 4. And that one will need 1. Let's say 2. That will have 2 hydrogens. This carbon has 3 H's, 3 H's, 3 H's. This carbon has 2 H's, and that one will have 1 H. So this will have 2 H's on it. I guess I'm going to kind of draw it small. And then this will have 3 H's. So that would be called isopentane. If you had to draw that for an assignment, isopentane would look like that. Now, it is an isomer. Well, it turns out there's another one you can do. And what you can do, I'll show you this. 1, 2, 3, 4, 5. Okay. If I want to try to draw all the possible forms of pentane I can make, I can break that off and put it right here. Okay? And that becomes the same as this, actually. This is iso. 1, 2, 3, 4, 5. But there's another way you could do this as well. And what you can do is you could, let me see. You can make it so that it looks like this. It's isopentane, N-pentane, and then there's one called neopentane. And what you do here is looks like that. Isn't this a strange one? So look, carbon 1, 2, 3, 4, 5. So you have CH3, 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 and the middle carbon just has a carbon only. But you still have C5H12 all the way. I don't really want to draw the whole diagram of it. So, you know, when it says to draw the isomers, like on my worksheet, I'm going to give you an assignment. You can just draw these things. It's okay. You don't have to go and draw all the H's. But if you did want to draw the H's, you'd say, well, here's a carbon, there's a carbon, there's a carbon, carbon, carbon. And then you have HHH, 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 HHH. Some people do that. They just do lines instead of writing the H's out, okay? But and that's okay for a shorthand. But in one of my worksheets, you'll see that on a shorthand. But if you're asked to officially draw something, you can do the shorthand, but then next to it draw the real one. That's kind of a weird-looking thing. That's what it looks like. But the point is to show you the bonding is different. Now, these chemicals have different properties when their bonds are moved around like that. And you'll see some things later. It's amazing. There's some stuff where I've seen, like in probably your textbook, you can find it. It'll say, this form, it has like a sweet, nice smelling odor, like from a plant, you know, like a plant or whatever, a flower. But when you change it around this form, oh, it smells horrible, like, you know, bad, nasty smell. So, colors can change, all kind of neat stuff can happen. Okay, so you don't have to memorize these, but what's the point of the isomers? Okay, this is something, here is something that I've always wondered, and the teacher before me always thought, I wonder if AP's ever going to do this, okay? Could they ever give you a question like this? Like draw all possible isomers of hexane. Draw all the possible isomers of hexane. Now, they wouldn't ask you to do that, okay? But they might say, here's hexane, draw an isomer in the box. Or, you know, draw 3 isomers. I don't know. But if you wanted to, like, really test yourself, do it this way. Now, for, what did we start off with? Propane. Propane, isopropane. There are only 2 for that one. Okay, for butane, there's a 3 I showed you about. The butane, I'm sorry. I mixed it up bad. It was not propane. It was, no, propane does not have one. Okay, we'll show you why for later on. Maybe I'll get into that. Butane. It was butane, isobutane, then there was only 2 for butane. For pentane, there are 3. I just showed you. Pentane N, normal. Then there's isopentane, and then there's neopentane. But even if you don't name them, let's just see how would you go about this thing with hexane. 1, 2, 3, 4, 5, 6. Now, if you wanted to, you could pause it and see if you can try to figure out a lot of these. Okay? So one thing I can do is I can always make the iso group. So let's just take off one arm and let's just stick it right there. Okay? So make it like that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. That would be one of them, like the iso. And you don't have to worry about naming it. Don't worry about even naming it. One of them is the normal, so that's 1. That's 2. Another thing you could do weird here, I could actually pull that one off and put it there and make this. Okay? So that would also be an isomer of hexane. Another thing I could do, let me think, 1, 2, 3, 4. I could take that and put it down below, like straight down like that. Now, sometimes you have to look at this and say, well, what would happen if I took, let's draw this, let's draw this one. Okay, I got a good idea. I got a good idea. Let's just say if I drew this, I took it and I said, well, I'll take that off, that arm, and I'll put it right there. Well, you know what? I just made the same as that one. Look at it. I mean, it's not exactly perfect, but yeah, iso, then this goes to straight to there. We went down here. Then another one. That's the same thing. So that's not an isomer. Okay? Well, here's another one, too, you can do. What if you say, well, I started with hexane. What if I take this arm off and put it right there? Well, now, it's still the same as that one. It's just the mirror image of it. Because you still have the iso group, and that one, and that one, and that one. And if you were to build something like that with a molecule set, you say, oh, well, if I put it there, well, then all I would say is, just turn it around. Oh, it's the same thing. So it's not really an isomer unless it is a different unless it's a different bonding set. 1, 2, 3, 4, 5, 6. Okay. Let me think. Then you can also make. Okay, so one thing you can do, you can make the normal group. We always know the normal group. Once you get to past pentane 5, then you can say draw the normal group starting with 5 and up. Draw the iso group. That's where you have a Y, and then also you can make the neopentane kind of group we talked about. Neo with the 4 group. So like if I did that, okay, and I'll kind of go up like that. Let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That would be another one you could make. That one, yeah, that would also work. That would be a different one. In fact, that's all of them, I think. I was going to check my list. I have them too, yeah. So, okay, so there are 5 total that you can draw for hexane. They're not going to ask you on the AP to draw all possible isomers of hexane because it would be so time-consuming to do it. But the thing is, if they gave you one, they could ask you to draw another one. So it's probably a good little exercise. But now there's even more to this story we'll be getting to later on. First, you draw them, but then you'd have to be able to name them as well. Like, what do you mean name them? Yes, they all have special names, and it helps to do this one. Like, actually, this one is actually called, even though it's called hexane, the technical name of that one is actually going to be 3-methylpentane. 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 That's the name of that chemical right there. Now, you wouldn't need to know that yet. I'm going to be getting to that in the next section. Okay, so now you know isomers. And so there is a little worksheet. One of the assignments is draw, I think, all the isomers you can of heptane. So, as I told you, one little secret is, it's just more like a fun thing to do kind of in a way. But, well, I don't know if you think it's fun. But draw the normal one straight out. Then draw the iso with a Y, and then from the Y, then start counting out. And then draw the plus cross thing, and then from there go on. You can do that with everybody, every element, every compound from pentane and higher. Okay, so you know what? The next section will be on the branched alkanes and naming them. And so I'm gonna pause it here and stop. So that was video number 1 of organic. I'll see you guys.